Practice exam 2, part 2. Okay, so we're up to question 3. What premise would be needed to derive the following conclusion by exportation? The conclusion is if A and C hook A. Okay, so this is the answer. A hook C and A. So exportation and all the other rules you need to be able to state symbolically. Do remember that the rules of inference are presented differently from the replacement rules, right? You can look on the inside cover to see, right? The rules of inference, the ones from Unit 7, you've got 1, 2, or for one rule, dilemma, 3 premises. So for all the replacement rules, you've got the premises above a line, and then a conclusion, and then slash, triple dot, and then a conclusion below the line. Whereas the replacement rules from Unit 8 are all in pairs of statements separated by 2 pairs of dots, right? And of course, there were 2 very important differences between the use of those rules indicated by that, and I'll come back to that in a minute. But if you remember when I was lecturing on Unit 8, I warned you that in the actual exam 2, there was a bit of a trick question, right, which is testing you on your knowledge of the difference in use between replacement rules and rules of inference. So let me remind you of that warning again here now. And here's an example of a question similar to the trick question that's on the exam. All right, so this is a question. This isn't on the practice exam, but I'm just putting this up. What premise do you use to derive this formula by conditional exchange? Okay, it's a disjunction, A by conditional B, or not A or B. Okay, so recall the form for conditional exchange is this. You've got, so those are the 2 dots, 2 pairs of dots. If P then Q, 2 pairs of dots, not P or Q. Okay, so remember what is indicated by these 2 pairs of dots. You're to read that as is logically equivalent to, right? The big difference between the Unit 7 rules of inference and the Unit 8 rules of replacement, big difference between the top half and the bottom half of the inside cover of your Klenk text, is that the rules of inference, top half, the relation between what's above the line, premises of the rule, and what's below the line, the conclusion of the rule, is a relation of logical implication, right? Whereas the replacement rules from Unit 8, bottom half of your inside cover, the relation between the formula on the left of the 2 pairs of dots and the formula on the right is a relation of logical equivalence. It's a stronger relation, right? Logical equivalence. And because it's a relation of logical equivalence, there are 2 things you can do with replacement rules that you cannot do with rules of inference. One of the 2 things is you, replace rules of inference, Unit 7 rules, you can only go from substitution instances of the premises to substitution instances of the conclusion. You can only go top to bottom. You cannot go bottom to top. Whereas one of the 2 things you can do with replacement rules is you can go from an instance of the right-hand side to an instance of the left-hand side, as well as going from an instance of the left-hand side to an instance of the right-hand side of these logically equivalent formulas. That's for these rules. Okay, so with that in mind, you might look at this question and say, okay, so what formula would I need to derive this by conditional exchange, which is a replacement rule? Well, what's the form of this statement? It's a disjunction. The overall form of this statement is a disjunction. Okay, so now I'm actually sort of giving you the things you need to know to answer the trick question on the actual exam too, all right? The form of this thing is a disjunction, so which of the 2 sides of the rule is it going to fit? Well, it would have, this is a conditional, this is a disjunction, so it would have to be the right-hand side. This would be the right-hand side, so I'd be going, if I'm deriving this, I'm deriving that from something of this form, so I want to transform this whole thing into a conditional, right? It's going to turn out that I'm on the wrong track in trying to answer it this way. But that's what you might think, and then you think, okay, so this whole thing has to be in the form of this, but now you get stuck because you realize the form is actually not P or Q. The form is actually a disjunction, right? Remember part 1 of practice exam 2? I was stressing in answering the question of whether these statements are or are not substitution instances of that form for question 2 of the practice exam. You say the form, right? Say this form. Right? That's why those questions, page 139, 40 from Unit 7, right? Question 1 from Unit 7, whether these statements are or are not substitution instances of the form, why they're such good questions, because they get you doing what you need to do to apply the rules properly, right? Say in words what this form is. Well, it's a disjunction with a negation as the first disjunct. Right? It is a disjunction. That's the major operator, and the first disjunct or the left disjunct is a negation. If you say that and you ask, is this of this form? The answer is no. This is not a substitution. This whole thing is not a substitution instance of this form because the left disjunct is not a negation, right? The major operator of this subformula is the biconditional. This is A biconditional B, right? So, this formula is, so I want you to sort of realize how you could get stuck here. This is how you might get stuck in the trick question in the exam, right? This is a perfectly legal list. There's no typos in this question, okay? The question is, what premise do I need to derive this by conditional exchange? This one, okay? A by conditional B, or this. Oh dear, I have now realized that this formula is not the left nor the right, is not in the left-hand side form or the right-hand side form of this rule. Surely he's made a typo. I have not, right? So what's the key to finding the answer? It's in the second difference in the use of replacement rules to rules of inference. Remember, replacement rules, because the formula on the left-hand side and the formula on the right-hand side is a relation of logical equivalence, you can use replacement rules on subformulas. Now, if you use a replacement form on a subformula, what you would do is keep that overall form in place, right, and just transform some subformula which is in the form of either the left or right-hand side of this rule. So let's list the subformulas of this formula. This guy, which is a biconditional, which is clearly not in either of these two forms. And this guy, oh, look at him. He is a disjunction with a negation for the first disjunct. Okay, so that's the key to my answer, right? The answer is, so since I'm going to apply this rule simply on a subformula, the overall form of the formula stays in place, right? It's still going to be a disjunction, and my left disjunct will remain unchanged, right? But what I'm doing, the application of the rule, right, is what premise do I use to derive that? So I'm sort of deriving this from this, but this is my answer. That's for answer, right? A biconditional B or A hook B. There I am going from the right-hand side of conditional exchange rule to the left-hand side. Okay? So that's a question where you really need to be aware. It's a question that shows you really need to be aware of the fact that with replacement rules you can use them on subformulas, right? Okay. No, not end. I'm just going to say some answers to 4 and 5. Okay, I won't write these up on the board. Question 4 is justify step 3 in the following derivation. Right? We should all have this file. Sorry, question am I up to? Yeah, question 4, right? Question 4, justify step 3 here. This is that you should all be able to recognize this, I hope, as a very simple disjunctive syllogism, right? So to justify, you just write d.s.1, 2, right? You've got to be able to recognize that such that premise 1 is a disjunction, major operator is a disjunction. Premise 2 is the negation of the second disjunct. And those are the two premises, disjunctive syllogism. concluded, sorry, the second premise is the negation of the first disjunct, and you've concluded that therefore the second disjunct is true. Right? It's just simple application of the rule of disjunctive syllogism, and if you've done a lot of exercises, you would have had a lot of practice with that rule, because it's used a great deal. Question 5, state the following rules symbolically. Dilemma and contraposition. So usually I now say, you need to be able to state all the rules symbolically, but now we're doing open test exams, but you do need to know them. Dilemma is a special rule. I won't even put it up, you can just look it up on the inside cover, but it has 3 premises. It's the one rule of inference that has 3 premises. It's P hook Q, premise 1, R hook S, and then P or R, the 2 antecedents, conclusion. The conclusion is the two consequence of the conditionals. Anyway, look at the rule. It's easy to see in symbols. Contraposition is often used. P hook Q is it's a replacement rule. So if you're asked to do it, present the rule symbolically, make sure you also express whether it's a rule of inference or a replacement rule. If you're asked to, right? So contraposition, state that symbolically. You want to do the 2 dots, right? It's P hook Q goes to not Q hook, not P. All right. All right, that'll do for part 2. We'll come back and do the theorem, the first theorem of question 6 to start part 3.